Alright, so this video is about how to find the model of best fit. So first, let's say you have all this data. You have all your linear functions for your Oakland and your other city. Then you have your quadratic function and for your other city as well. And you have the exponential function and for your other city as well. Then you have all these coefficients of determinations here. So here's all of these. And remember I told you all that if the coefficient of determination is close to 1, then that means it's a good model. So out of all of these, so let's just focus on Oakland here. And this is all made up data. You will have your own data. Let's focus on Oakland. So the best coefficient of determination is this one because 0.997 is closer to 1. Therefore, when I make my predictions, I'm going to use this one for my Oakland. I'm going to use the quadratic model to make my predictions for Oakland. Now let's take a look over here for my other cities. So here's my linear, there's my coefficient determination. So the best coefficient of determination is this one because this one is closest to 1. It's 0.987. Therefore, when I make my predictions for this data, I'm going to use the quadratic. For my other city, I will use the quadratic. So you might have a linear and a quadratic, or you may even have an exponential as your best fit, and whatever. So it depends, and your data, whatever you decide, has to fit and back up what your data has. So this is just a made-up example where we have a quadratic for Oakland and a quadratic for the other city. So now that you have that, you're going to head into Desmos, and this is to find the point of intersection. So basically, the question we want to answer is, when will these two cities have the same population? And how you answer this is if you go to Desmos. So my model of best fit for Oakland is this function. My model of best fit for my other city is this function, and I figured that out using the r squared or the coefficient of determination. So I'm going to go on Desmos and graph this function and this function and find out if they have a point of intersection. If they do have a point of intersection, then that will be the point where they have the same population because that means their y's are equal. When their y's are equal means that's when they have the same population. So let's go on to Desmos. And let's, I'm just going to copy and paste my equation here. So this is my model of best fit for Oakland. So I'm going to go ahead and paste. So I have to rewrite my x squared right here. Then I'm going to copy and paste my best model for my other city. Again, I have to fix this. The copy and paste didn't record that x squared. Okay, so we have that graphed. The only problem is we again can't see it. So you're going to want to have to input your original data. I don't know. So I think I started this in like 1990 or something like that. Let's go up to like 2020 or 2030. That's around the time that the data was recorded. Let's go 0 for the y like usual. And usually you want to put what max y value you got. Let me just put the y-intercept and let's just see if I get a graph here if I put that. So I start seeing a line. That's good. If you start seeing images, so let me zoom out a bit, then that means you're good. Oh, here we go. Here's my two parabolas. Great. Now I want to find the point of intersection, and keep in mind your two graphs might not even have a point of intersection. You have to show that visually. So I see that they intersect at two places. Let's figure out where they intersect here. So this one intersects right here. The x is a negative time, so negative something something years from 2000. You're gonna want to, you could figure out what that time is. It could be like it's before the thousands, but I wouldn't pay attention to the negative time here. Let's pay attention to the time that makes sense, which is the positive time. You could interpret that other one if you want. That would be cool. But let's go find the positive time. See this 2500, the year 2600. Let's keep going because I saw it intersect somewhere over here. Keep going, keep going. It might take you a while, but here we go. I guess Desmos already kind of pinpointed their point of intersection. So remember, x was years, y was population. Therefore, according to Desmos and according to my models of best fit, when I plotted these two data, it says that in the year, approximately in the year 4,334, I'm going to have this much people. And if you remember your scientific notation, that just means move this decimal to the right 8 places, so it's a pretty large number. So now we figured out when these two cities will have the same population. And this is all an estimation because, again, these are models of best fit. Mathematical models aren't always accurate. So that's how we figure out the point of intersection. Next off, you want to figure out the predictions for 2050. So let's take a look. And like I said, you have to be detailed. I just wanted to make this fly in. Okay, so anyways, for predictions for 2050. Okay, so now we found out when the two cities will have the same population. Now we want to find out what each city will have for the year 2050. So because my coefficient of determination for Oakland was the best fit for the quadratic model, I'm going to use the quadratic model to make the 2050 population. If your best fit is not the quadratic model, it's a linear model, then you're going to use a linear model. It all determines on what your R-squares are, and they have to match up with your data or it won't be accurate. So here's my quadratic for my Oakland data. Y is population, X is time or years. So I'm going to plug in 2050 for X. So I go ahead, put that in the calculator. I get that supposedly in Oakland, according to this model and according to the data I collected, it's going to have this much people. All right, and then again, because the coefficient of determination for the other city was the best fit for the quadratic model, I'm going to use this model to predict the 2050 population. Like I said, sometimes the model to predict Oakland is quadratic, linear, or exponential. Sometimes to predict your other city, again, it could be any of those threes. You have to back it up. If your R squared matches up and is the best fit for that city, then you're going to use that model. In this case, I showed you two cases where the quadratic was the better fit. So anyways, for the other city, the quadratic equation was this. So again, Y is population, X is years. So you're just going to plug in 2050. That's how you're going to figure out the population in 2050. And here it says we get a negative population, which makes sense according to that model, but it doesn't kind of make sense in real life, to be honest. Because how can you have a negative population? Because it does show that around 2050, this is the blue line right here is below the x-axis, which means it would be negative. And that's how you would make your predictions. And this is how you would argue to finding the point of intersection. You would want a screenshot of how you found that. You would also, if your lines, whatever your models of best fit don't intersect, then you want to show a proof of that. Take a picture in Desmos to show that they in fact don't intersect. And that will be enough proof for you, but you got to elaborate on how you figured this out. So all these steps I explained to you, I'd like to see that elaboration on your PowerPoints in the notes section.